Hello and welcome to Living Proof, the Isaac Newton Institute podcast. My name is Dan Aspel and I'm your host. In this episode, I'll be speaking to Simon Cox and Adil Mughal of the GeomPack programme, full title Geometry and Packing in Material Structure and Biology. This is the second ever I&I satellite programme, following a similar event at the University of Reading in 2022, and in this case was planned to coincide with the 150th anniversary of the host institution, Aberystwyth University. Simon and Adil will be speaking about their fascinating topic, as well as the joys and challenges of running an I&I satellite programme. We hope you enjoy the episode. Hello and welcome to Living Proof, the Isaac Newton Institute podcast. So in today's episode, we are coming from a slightly different location. We are in Aberystwyth in the height of a late summer heatwave. And with me I have Simon Cox.
Hello.
And Adil Mughal.
Hello.
So it's a pleasure to be here with you both. And we're here because we're in the final few weeks of your programme. Do you want to tell me a little bit about that programme? And first of all, tell me the title, because it's an exciting one.
So the title of our program is Packing and Geometry in Material Sciences and Biology. And so, of course, that sounds like covers quite a few things.
So we call it GeomPack.
So GeomPack, and what's the significance of GeomPack? Is that a combination of all of what we've just heard in that title?
Geometry and packing.
Okay, excellent. Yeah, so rolls off the tongue.
And so I would say there's lots of people from here who come from the soft matter community, and they understand, or they see a lot of stuff in their laboratories or their simulations that they do that involve packing of objects or understanding how geometry arises in soft matter problems. And so it really brings in a community of people who work in this area.
A very broad community of people. I mean, material science, physics, engineering, applied mathematics, pure mathematics. And so we've brought all these people together.
And you've been working together here for 3 weeks now, is that right?
Just over 3 weeks so far. Yeah. This is the last week.
With 1 week left, and as we say, summer has arrived. You've been kept indoors working hard by the drizzle and
exactly.
the cold weather, but now the test is really on because it's high 20s and the beach is calling.
Well, I kind of consider the part of the program that involves people getting to bond with each other and socializing as being important as well. So the fact that we have lovely weather here and people want to hang out and talk science with each other, I think is also an important part of the process.
Even on the beach, you can discuss packing, right? Grains of sand that you need to pack in a particular way to make your sandcastle persist through the next high tide.
Sure. Yeah.
And it's interesting, you're speaking about the interactions between people, because Adil, you're a veteran of a few Newton Institute events, programs, workshops, etc. So you have that experience of what one of these programs has been like in the past, although this is only the second ever satellite program. So in Reading last year there was the first and Aberystwyth was the second. How does it compare to your experience of the Newton Institute in the past?
Well, I've always come into programs of the Newton Institute as a junior member, somebody who is turning up to learn from other people and collaborate and make connections. All those kinds of things that the Newton Institute meetings are really great for. And I think that what the difference here really for me at this meeting is that this is the first time I'm organising something such as a residential meeting under the auspices of the Newton Institute here at Aberystwyth, and so it's a totally different experience for me, and I'm beginning to learn and understand what's involved in that, and it's been a very useful experience for me to understand and begin to make connections in this area.
Yeah. And Simon, when we recorded our video interview earlier today, you were saying about how it ties into the 150th anniversary.
That's right. Well. So Aberystwyth University, or as we call it now, it was University College of Wales, Aberystwyth, back in 1872 when the university started. And of the three members of staff, one of them was a mathematician, a Cambridge mathematician actually, Horatio Nelson Grimley. And so he came here and he started the teaching of mathematics 150 years ago. So the university is celebrating an anniversary, so is the department.
Oh, what a perfect time for this to have been arranged, yeah. And so you've been spending time together, I guess much in the same way that people would with a standard I&I programme. You've had programme participants, you've had guests for your workshops. And you've had guests as well, which I'd like to ask you about in a bit more detail, visiting because of the specialism, because of the subject matter. So that sounds like it's been quite exciting.
It's been great, yeah. I mean, we've had people come from all over the world, west from the US, from Australia, a long way away, and all points in between. And so I think we could say 4 continents with some confidence. And as I said before, from a very broad range of backgrounds, with very different interests. And so this, Adil talking about bringing people together, getting them just to talk to each other is half the battle, because you won't do mathematics together until you know each other a bit better. So that's been very rich.
Also, this is a culmination for me of a bit of a journey, in that during the pandemic, of course, like everybody else, we scientists also became very isolated, but there was a great need for everybody to continue communicating with each other and talking and so on. And one of the things that I started during the pandemic was an online series of Zoom seminars, and this became on packing and geometry, and this became really successful. And so people started to coalesce around an online community, and we'd have talks every fortnightly, for a couple of months, and people presented their research, but also got to be able to speak to each other, despite the fact that they were under lockdown in various countries and so on. And we found that the idea of having these Zoom seminars, people wanted to carry on doing that after the pandemic was over. And so in a sense we had a sort of a natural built community already. And so when the normal freedoms of our lives returned once again, the idea of having an in-person meeting was obvious and clear. And so that's what this meeting is really about, is to bring as many of those people who are participating in that online community to a shared space together in one location.
And so we've included that Wednesday afternoon seminar slot as our public lecture slot during the programme. But of course, because we've got the Newton Institute streaming service working, all the people who normally attend the GeomPack seminars who haven't been able to be here all the time or for some of the time can watch that at home. And so there's that momentum has kept going.
It's really exciting from my point of view, as someone who's not a mathematician but has a strong interest in it and hears a lot about it a lot of the time, because the in for your particular topic is quite grabby. I can understand what you're talking about when you start talking about the puzzles of packing, and it sounds fascinating and strange and interesting. You said earlier, Adil, in our video recording, when people ask you what you do, you say, how many marbles can you fit in a pint glass?
That's right.
What's the best method of doing it? That's fascinating, and I can visualise that immediately. And I'd love to hear more about the subject and from that start, and how it presents itself in its challenges and its interests.
Yeah, so that's exactly right. When I often get asked at dinner parties or gatherings or whatever, people ask me what I do, and they say I'm a mathematician. So I say, what does that mean? I say I study packing problems. And so they want to know what that is, and often I say, the example I give, the go-to example I have is, given a pint glass, because I've often got a pint glass with me, and as many marbles as you wanted, how would you arrange the marbles so you can pack as many of them in a pint glass? And that's actually an example of a packing problem. And as silly as that might sound, some of the oldest packing problems come from this kind of area, and often it was driven by the naval industry, by naval ships, naval warships, who were interested in understanding how they could pack as many cannonballs into their hulls. And so it is quite surprising where some of these things come from. But yes, they persisted as problems in mathematics, but also in military adventures and industry for a long time.
So the idea of packing spheres it leads on, though, doesn't it? Because for those of us who are looking at it from a sort of quite superficial level, you can imagine a marble, you can imagine a cannonball, but it applies to much more sort of deeper and more significant things, unexpected things, not just sort of physical objects that we can touch, but things at a deeper level.
Yeah. So for me, one of the most interesting examples of this happens to be how biology often interprets packing. And so if you've ever looked at the head of a sunflower and seen the spiral patterns that you have there and the mystery of why these occur in Fibonacci numbers, well, much of that has been talked about within the packing community for decades. But actually, perhaps even more deeply, packing problems have been some of the most knottiest problems in mathematics for centuries. And the most famous example of that is something called the Kepler conjecture. So Johannes Kepler proposed that the best way to pack equal-sized spheres in 3 dimensions is what you normally see a greengrocer doing with the oranges. You would first make a layer of oranges packed as densely as possible in a hexagonal formation, and then in the hollows formed by those oranges you pack the next layer, and so on and so on. And while the greengrocer knows this is the best thing to do, it's the proof that eluded mathematicians for nearly 500 years. And it wasn't until the last 20 years that Thomas Hales, who was here at our meeting, but he's very famous for having finally proved the Kepler conjecture and shown that that really is indeed the best way to pack equal-sized spheres in unbounded 3-dimensional space. So it just goes to show that these things are easy to state, but often very difficult to resolve.
It must have been a very easy sell when you presumably contacted Thomas to ask if he wanted to join here.
I like to think so, yes.
Because it couldn't be more perfect for
That's right.
his area of research.
Yeah, there's only very few dimensions where it's known that what the optimal packing arrangement is. I think 2, 3, 4, 8 and 24 dimensions. So there's still a lot of problems to tackle there.
And we've spoken about spheres so far, but it's not unique to spheres.
Indeed not. In fact, the field has really exploded in the last 10 or 15 years, brought about by 2 major advances in my opinion. Firstly is how computer simulations have allowed people to think about the overlap or contact between objects which are not spherical. And added to that is the enormous use of GPU computing, which has accelerated this area significantly. And this has allowed scientists to look at the packing of non-spherical objects, ellipsoids, tetrahedra, cube. There's a vast zoo of different types of shapes that can be simulated now and understood how they pack in their most densest form in 3-dimensional space.
And other dimensions.
And
again.
other
I'm
dimensions.
still trying to get my head around a packing of 3-dimensional polyhedra on the surface of a sphere in 4 dimensions.
That's right.
Okay.
Yeah.
Which we saw results
Yeah,
from.
we did. Yeah. And the other big advance, in my opinion, is scientists working in colloidal chemistry where they manufacture tiny building blocks on the micron scale have now advanced to the point where they can make these reliably, not just spherical objects, but objects such as cubes and ellipsoids and so on. And now they're able to see in experiments what happens when these objects are packed, and that has really pushed our understanding of packing into self-assembly now. And people are asking, how can you manufacture tiny microscopic objects with very interesting properties, often how they interact with light, for example.
This is a slightly ignorant question, but lots of what you're saying sounds like this must be applied mathematics, but also some of it sounds like it might be pure mathematics. I don't know. Is that fair to say, or is this very much applied?
There is a mixture, undoubtedly. That
what would you describe it to people as, typically?
I really would like to emphasise the interdisciplinarity. You need the inspiration from the simulations that Adil is talking about to know what sort of solutions to look for. But if you're trying to make a definitive statement about what the best solution is, what the best arrangement of objects of a given shape is in space, in dimensions, you need pure mathematics.
Yeah, I just echo that and say that the study of packing problem has really started to cut across many different fields, and we're seeing applications in areas such as understanding how foams, arrangements of bubbles are formed or arranged in space. That's also now can be thought of as a packing problem. We've already talked about packing of hard objects such as tetrahedra and so on. But there's lots of other things in biology which still astound us. So think about viruses, for example, and these viruses contain genetic material which is a bit like a very stiff wire which has to be packed into a cavity. But how it does this, how it manages to force this wire into that cavity and keep on packing a very long string under enormous pressure is really a mystery. And then, of course, as soon as the virus finds its host, it attaches and opens up the valve, and all that genetic material goes shooting into the cell. So how does it do that without the material jamming in the valve in the first place? I don't know.
Without a GPU.
Exactly.
Gosh, yes. It'd be satisfying to find out how to stop them from doing it.
Well, sure.
Yeah, it's fascinating. There seems very little that this doesn't spread into. So I can see why you're so passionate about it. The last 3 weeks, obviously, as you say, have been quite intense. Do you feel like there's new direction as a consequence already? I mean, it's quite hard to say because a lot of the time the outputs from this kind of work come from the collaborations, and it may be in the months or years to come that you'll work together with new connections. But has it been a sort of scientifically an exciting period for you?
Speaking for myself, I have a whole list of things that I'd like to go and investigate further.
Yeah.
A whole list of people I want to do more things with, and so that's been really valuable. And it's also been really good to see participants meeting each other and going off using one of the breakout rooms and saying, let's talk about this and see if there's something in it. And so you're right, we don't expect a paper next week, but if they stay in touch and continue to work together, then I think that's a success.
Yeah.
So we were really lucky in this meeting to have Keim Goodman-Strauss come and visit us, and him and his team have recently discovered discovered, I hope is the right word, proved that a particular type of shape called the Einstein tile is a mono tile, a single tile, which when tessellated on the plane with itself produces a non-repeating object, an aperiodic pattern. And it was wonderful to hear about just how mystified he still is about this, how it works and so on. And I think people like myself, Simon, Keim and so on, we're going to be spending years from now on still thinking about how it all works and working out the implications of all of that.
You brought some little versions of these tiles and put them on the table downstairs where people can mathematicians surreptitiously sidle over and some of them persevere, some of them give up because it's not clear how to put them together to just keep going to fill space if you don't know the rules. And so I mean that I guess is his contribution is to determine the rules and prove the aperiodicity.
Well, I think we should see those at science fairs and events for a few years from now. Yeah,
I think there'll be popular Christmas presents as jigsaws as well.
Yeah,
sure. He shows a picture of someone with it tattooed on their forearm.
Really?
Yeah.
Wow. Yeah, I mean it is significant. So
it's just lucky that there was no mistake in the proof. Otherwise.
Well, so that generated the question: if you go all the way around your arm, does it meet up again? Is it possible to have a tiling on the cylinder, the surface of a cylinder?
I mean, it's really fascinating to hear, and I would like to ask more questions about the science, but I guess we could talk for hours. But let's have a talk about the actual mechanics of this program as a whole, because it's, as I said earlier, this is only the second satellite event that the Newton Institute has approved. And how's it been for you? What sort of learnings have you come back from it? It can be from the very practical things to the sort of more theoretical, but in what ways has it been a success, and in what ways do you think others could learn from your experience?
It's been fantastic to have people come to Aberystwyth for an extended period of time, something that as a department we couldn't have afforded to have all these people for this amount of time to talk to each other. colleagues across the university have commented to me how wonderful it is to have the place feel lively in the summer when normally staff are on holiday, the students have gone. And so we've kind of taken over this building and sort of hidden people all over the place, from the library upstairs with its view over the town and the sea, to the meeting rooms, to the foyer where the coffee is freely available all the time, and people can do this famous turning coffee into theorems. So that's
a great way of putting it. Might change the INI's Twitter handle to say that, turning coffee into theorems since 1992.
I'm sure I didn't coin the phrase. Yeah.
I like it. Yeah. Yes, but continue, please. Sorry.
And so it's brought us into contact with more people around the university, arranging accommodation, arranging hospitality for lunches and so on. And it's brought in more people, both from mathematics and from the physics department, from biology, to come and see not just what we do, but where what we do links with what other people, other places in the world do. Particularly with the biological link, there's clear overlap with people working on related problems.
Yeah, and it's making those connections, isn't it, that can be key and also quite challenging, trying to convince biologists to take part in.
Well, I mean, and again, that's one of the advantages of such a long programme, is that we haven't had talks from 9 to 5 every day. We've had a couple of talks a day, and then people have had time just to reflect, to discuss, to go away and look at the literature, very much in of course, the Cambridge style of things. And so we have had space to think about things.
And have there been any sort of challenges, anything that if you could go back, that you would do differently from the beginning, that others might consider for their own satellite program applications?
I would say that there is a difference being situated in Aberystwyth as compared to Cambridge, and that probably has its advantages and disadvantages. And so I think maybe in the disadvantage side, Cambridge has a very high density of academics there already, and a lot of itinerant academics coming through Cambridge all the time. And so it's nice when you have people who are in the area who can sort of jump in and kind of contribute to a little bit here and there. But on the other hand, having this meeting here in Aberystwyth has really meant that it's felt like a little community of our own. And I think that process of bonding has been much stronger. Whereas maybe if you're in Cambridge, you might visit the program and you kind of go, oh, that's very nice, but you might also pop off to some other lab to have a look at something. But here people have been brought together, and I really feel one of the things that strongly emerged from this meeting is that everybody got the chance to talk to everybody else. And so often when you have very busy meetings, there are people who sometimes you don't get a chance to speak to because they're very much in demand or they're busy. But here it's been a lot more relaxed, and everybody who wanted to speak to so-and-so and whatever has had the chance, ample chance to do that.
People have commented that it's not like being in a little hotel in the forest with nothing else to do, but Aberystwyth is also distant enough from large cities that once people are here, they stay here and they get involved and they talk to each other. So we've benefited in that respect. That there hasn't been a series of people saying, I'm going away for a couple of days to give a seminar there and coming back. We've all been here together. And you bump into people. You can walk down the prom and there'll be somebody doing the same thing, going the other direction.
And you mentioned that you've taken over the building here, because we're in the mathematical, it's the physical sciences, physical sciences building. And has there proven to be enough collaborative space, open space where people can work together? Because the reason I asked that, I suppose, is because the Newton Institute building, although it's over 30 years old now, it's built around the idea of everyone's offices opening into an open space and there being tables, and you can't escape each other and there are no corridors. But has it been easy for everyone to collaborate well here?
Sure. In fact, we're very lucky in the physical sciences building to have the physical sciences library on the 4th floor, which is a large open plan space with lots of desks and working space for people to be able to take over on 2 floors, and so people can find somewhere where they want to sit down and be available to chat to other people if they happen to walk by, or they can find a secluded corner where they can just sort of retire and do their own thing for a bit. And I think we've really been able to replicate some of that Cambridge experience in that sense.
If people need to go and Zoom, then the accommodation where people are staying is 5 minutes walk away. And so if you really need some privacy, that's possible as well.
So all good things to bear in mind for anyone who's listening who may be thinking about proposing their own satellite program, is that shared space is kind of very important to the success of a satellite program of any kind. Yeah. And okay, so I mentioned that this is you've had 3 weeks already, and we're in the final week now. So what does the future hold to wrap up? How is the last week going to end strongly in your opinion, and what lies beyond after this point once it's finished?
So we'll have our 4th GeomPack Wednesday afternoon lecture, which is about the gyroid and why it appears in so many natural settings. So I'm very much looking forward to that. And I think it'll be a highlight of the programme. And then this week we're starting to look beyond what we've done this month to the sort of networks that we want to have in place in addition to the GeomPack seminars, and where we would get funding for that. That's kind of a focus, I think.
Fantastic. Well, as I said before as well, the weather has turned really nice, so you're showing great willpower in here working. Although I'm sure the evenings will be full of fun. I believe you mentioned earlier you were talking to other colleagues, and you have social events, don't you? So you'll meet up in the evenings, I hope. And
indeed.
Yes, social events have been a very important part of this. I wanted this meeting, both me and Simon wanted this meeting to be about science, but also to give people a chance to socialise and have a good time. I think it's very important.
Absolutely. Yeah, otherwise you may as well just be working at home and connecting for a Zoom chat and then getting on with your life. Yeah, otherwise those connections don't form, do they? So fantastic. Well, thank you both very much. It's been such a pleasure, and I look forward to seeing what happens with GeomPack from this point onwards. So thank you again.
Thank you.
Thank you.